Hi, how's it going? In this video, we're going to get object models working. To start with, hop into the project and we have this model here, a cube model. To import the model is very simple. We can just grab the folder that has the models, drag that in, copy items if needed. That is good. We have the cube object model there. Now, just a little bit of bureaucracy. We'll head to the model, to the render scene, and obviously we're going to be making cubes. And we will just go ahead and follow through, fix up all the other occurrences here. Okay, that's great. Then we'll go to the renderer. And fix this up here. We are looping through the cubes. Okay. Let's go ahead and create an object mesh file. So we'll go to new file, Swift file. I'm going to call this object mesh. Okay, so there's just a little bit of legwork to do here. What we're going to do is there's a package or a module called Model.io, which is used for saving and loading models. We'll access that to load the model data for a given file name, and then we will convert that into a MetalKit mesh. So I'll have a Model.io mesh to a MetalKit mesh. And let's just go through it. Okay, so that's quite a chunk of code there. What we're basically doing is we are loading in a Model.io mesh Again, that's the standard procedure for loading things in. We are converting that to a MetalKit Mesh. Now, what's it complaining about? So when we load things, we take in a file name for the model that we're going to load, and that is loaded in here. We generate a URL for that resource, and this just searches everywhere within the bundle, so everywhere within this project folder. All this stuff is the bundle. We have a device that we're going to use, and we have what's called a buffer allocator, which is used to allocate memory. So we then need to describe the attributes of each vertex. At the moment, we've just got positions. So as we add more attributes, this offset will become more important, but right now it's just very simple. So yeah, attribute is a three-dimensional thing. The position is three-dimensional, X, Y, Z. It starts off by default at 0, so it starts at the start of the buffer, and it has a buffer index of 0. So in our shader, we had a vertex array, which was buffer 0. Now, when we go into that shader and change it, it's going to be the mesh is loaded in buffer index 0. Okay, so we set that up. Then we set the stride. So what we're going to do is, as we add more attributes, we'll have heaps of attributes, but only one stride, only one layout for those attributes. Okay, so we, take that descriptor and convert it into a model IO sort of descriptor using this code here. Then this model asset will kind of load the object model and store that all here in the asset. And then to get the model IO mesh, we take this object, do this kind of complicated wizardry to cast it to a model mesh. As always, link is in the description down below. All right, so what do we do then? Then we convert this into a MetalKit Mesh, which is, so model IO mesh is for input and output. But MetalKit is really what Metal expects for drawing things. So yeah, there we have it. We have loaded an object model. So let's jump into the shader and modify things a little bit. Okay, so now instead of taking this vertex array and vertex ID, instead of that, we're going to take a vertex in structure and this is marked as stage in, but really that also takes up buffer position 0 as we set out in the object mesh code. Double checking everything. Yep. And we can get rid of this here. So again, as we get more attributes, we'll register them here and with our object mesh code, and that will register all of them. In a future video, we'll look at texturing. For now, I'm just going to leave this as hard-coded color. That's fine. Now, I was going to say, it's a bit strange that in this Where are we? In this layout here, we declared position as a 3-dimensional float. However, in the shader definition, we declare it as a 4-dimensional float. Metal does a few things behind the scenes. One of them is it takes that 3-dimensional float and it sticks a 1 on the end as a default value so that the translation will work correctly in this stage here. But yeah, no, that's fine. The shader code should be working okay. Now it's just going to take a bit of work on the renderer side. So we had, we have mesh. I'm going to make that is an object mesh. We'll go down here. Now we're going to need a few things. We've got a device, that's great. We're going to call this is cube.obj, so cube is our file name, but we also need an allocator. So no, I'm just going to leave that there for now. Okay, so we might want to load several object meshes. As a matter of fact, we definitely will. For that reason, we'll store the mesh buffer allocator as a class variable and use that for all of them. So we'll say okay, in order to do this, we just need a device. Okay, so then down below, we can pass in the allocator. So that should be enough to create, come on. What do you mean incorrect? Of course. Let me just retry that. It's being weird. Okay, object mesh. Device, okay. Okay, good. So then we go down. And I just noticed set pipeline state should be happening just once. Probably a good idea to do it as close to the render encoder as possible. Okay. And also setting the vertex buffer should only happen once as well. So if we have several cubes, we don't want to be setting the vertex buffer all the time. So we go ahead, do that now. And it is complaining because we have to access some things. We go metal mesh, and then vertex buffers. Just grab the first one, grab the buffer there. Okay, now to the drawing. So we'll go for mesh in. So loop through the submeshes. There should only be one submesh, which is the default thing that we're drawing. Then we'll go render encoder. Okay, so we're going to draw, let's go primitive type triangle, index count, just go get the index count from the submesh, index type, okay. That's looking pretty good. We can always give this a shot and see if it works. Spoiler alert, it won't. Okay, so we had a fatal error when the pipeline state was being created. And the funny thing is, it doesn't really tell us what caused the fatal error. Come on, what are you doing? Okay, no, it's just being slow. Okay. So what we basically need to do is we need to go back into the pipeline descriptor and set something. So we've got the descriptor, we've got the library, we've got the vertex function, the fragment function, that's great. We've got the pixel format. The other thing we need is the vertex descriptor. That needs to be described to the pipeline as well, so the shader kind of knows what it's working with. So we'll go pipeline descriptor, yeah, metal vertex descriptor from model.io. Then for the vertex format, we'll look at the model that we loaded in. Yep, of course. Of course. Now it's complaining that the mesh has not been created. Okay, so that's okay. We can just grab this creation line and push it right back up to the start. Now the creation of the mesh really relies on the allocator, so we can just do it any time after that. Good. Now let's give this a shot. And it is working. I'm just gonna I think these are previous runs. I wonder if I can just clear that. Other thing is it's going to change that to iPad. Okay, awesome. So we've got that running on our iPad. Yeah, and it complains because I exited the wrong way. That's fine. Well, looks like there are no issues. Okay, cool. Awesome. So it's working, no issues. For fun, let's change things around a little bit. So as you could see, that was just solid colors. We can also, I'll get to that in a second. Let's go to our render scene and let's put the camera up a little bit. So let's go a height of 2.5. Oops, that's the Oilers, sorry. A height of 2.5, and then we want to look down a little bit. So 90 degrees is horizontal, 110 degrees would be down a little bit. Good. Now we're looking down on our mesh. Maybe let's look down a little bit more. Good. That's good. That's fine. Now about the solid color. At the moment, we are not using any textures. That'll probably be the next video in this series. But for now, if we have a more complicated model and we want to visualize it a little bit differently, we can draw it as lines, and there we can see all of the faces. Cool. Anyway, I hope you had fun. Hope you learned some stuff, and that'll be it for now. I'll see you in the next one. Bye.